Well, welcome to this online revision session for AQA M2, in which we will be looking at the June 2010 question 5 on kinematics with differential equations. So you can see in this question we're told that a particle is moving in a straight line and at time t its velocity is v. We're told its acceleration is given by minus lambda over v to the power of a quarter, where lambda is a positive constant. We're also told that when t is naught, velocity equals u, and we have to find v in terms of u, lambda and t. Well, our starting point must be the fact that acceleration is equal to minus lambda over v to the power of a quarter, and since acceleration is given by velocity being differentiated, we can write down the fact that dv by dt is equal to minus lambda over v to the power of a quarter. And so we need to integrate this expression to find v. So in other words, we're going to separate the variables, which is a fairly standard method. So we bring the v across to the left hand side with the dv, and then that will equal the integral of minus lambda dt. And so now if we integrate both sides, increase the power by 1, that becomes 5 over 4, and divide by the new power, so divided by 5 over 4 is the same as multiplying by 4/5, and then that will equal minus lambda t plus a constant of integration. And to find that constant, we can then substitute. When t equals 0, v is equal to u, and so that will give us that c must equal 4/5 of u to the power of 5 over 4, which we can then substitute back in. So that's going to imply that 4/5 of v to the 5 over 4 must equal minus lambda t plus 4/5 of u to the 5 over 4. And so if we now multiply through by 5 over 4, that will tell us that v to the 5 over 4 is equal to, and we can put the positive part first here, so we get u to the 5 over 4 minus 5 over 4 lambda times t. Yeah, and then if we then have to do to get v by itself, we'll have to do the whole thing to the power of 4 over 5. So this will become u to the 5 over 4 minus 5 over 4 lambda t, all to the power of 4 over 5. Really just an algebra exercise in solving a differential equation. 7 marks for this. So for the starting point, realising you need dv by dt as an expression for the acceleration, you get a method mark. For then separating the variables, you get a mark. For then being able to integrate both sides and include the constant of integration, you'll get an answer for each side, and then a mark for including the constant of integration. And then for finding the value of c in terms of u, you'll get a mark, and then for the final answer for v, you get your final mark. Well, hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.